Hello, and thank you again for joining us. Today, we at Mars International are proud to present the next video in our webinar series, The Top 10 Mistakes When Writing Product Specifications. A product specification is a critical planning document for any design and contains all of the relevant information for a timely and successful product launch. In this video, we will not only show you what pitfalls to avoid, but also how to develop an effective specification. Our presenter today will once again be the president of Mars International, Jeff Engelstein. Over the course of his career, Jeff has been involved in or led the effort for just about every aspect of the product development process. He is calling on this extensive experience to highlight some of the most common mistakes made by companies and how they can get the most out of their specification. Thank you again for joining us. Please be sure to subscribe to our channel for future video releases and check out our website at marsint.com. Without further delay, I will pass it over to Jeff.
Thanks for that introduction, Jason, and thanks to all of you for spending some time with me here today to talk about specifications and attending this webinar. So before we get started, just to kind of define what a product specification is, and I'm assuming most of you know, but just in case, the product specification is a formal document that describes everything that there is to know about your product, and it's sort of a roadmap for your engineering team, for your development team, but also for your marketing team and your sales team and really everybody. It's kind of the heart of the project, and that's why it's so crucially important to get it right. Too often things are kind of left just sort of as an oral tradition, and it's not written down where people can go and see what it is. So kind of with that in mind, let's jump into number 10. Our number 10 product spec mistake is poor environmental and life cycle specifications. So what I'm talking about here is, that's is one of those things. As I mentioned, specifications are intended to cover everything there is about your product, right? Ultimately, they should cover all the elements that make it go. And while people think about functionally what it is, sometimes the environmental considerations or what we call the life cycle considerations are left out and don't really come into play until it's maybe too late and the product's already out in the field or you're making prototypes and something. And this kind of is falling into two categories here. So environmental are things like the operational conditions of the device. What is the temperature environment? What is the humidity environment? What type of vibration is it going to see? And often we will kind of break this into two different areas. So for environmental, we'll say the operating environment, but then also the storage and transportation environment. And those two are typically somewhat different. In terms of life cycle specifications, that's both the kind of the lifetime of the part. How long is the product supposed to last? We usually try to express that in terms of the number of operations. How many times can you push this button? How many times is this garage door supposed to open and close? And sometimes it can be a little challenging to kind of figure out what that is, but usually you can get some rough order of magnitudes for what that should be over the use of your product, how many times per day you're expecting people to use it, and so on, and then giving yourself an adequate safety margin beyond that. But the other aspect of life cycle also falls into other elements of like repair. For example, is this thing going to be repairable? Is this thing going to be something that you're expecting the users to be able to open up? And, even something simple as, they can change the batteries or you may be sending them a new display or something like that. To, more, complex stuff is when it's done. How is it disposed of? Are any of the elements supposed to be recyclable? Is it coming back to the factory for repair? Does the unit ever maybe need to be reprogrammed? When it's in storage, is there a concern about, batteries dissipating or causing some issues? So just thinking about all of the different elements of the life of the product, not just, kind of how it operates, but also, storage, beginning, and disposal. Number 9 is inconsistent or undefined terminology. What I'm talking about here is, this is, as I said, a written document. It's something that people are going to be reading. And so it's very, very important that when you refer to a specific button or a specific feature, right, that you always call it the same thing every single time. For a lot of common features, sometimes you'll use colloquial names for it. One area you may call it a power switch, and another area you may call it an on-off switch. It's very important to be extremely consistent with it. Sometimes it seems like it sort of would be common sense of what what it is, but when people are reading this, clarity is essential. You don't want to leave any room for misunderstanding. And a real simple way to do that is just to be consistent with your terminology and use the same term for the same thing every time. Also, specifications can sometimes get into some real details about referencing other specifications or other features or other regulatory things, and it's very important to define exactly what you mean by all of those terms. So leaving some of those things out, and then a year later or 2 years later, somebody picks it up and they're like, this spec is talking about this thing here, and I don't know what this is. I think I might know what it is, but I don't know definitely what it is. So be consistent in your terminology. Those of you that know me, I play a lot of board games and have designed some as well. And, one of the key things when you're writing rules or reading rules is to always refer to the same thing the same way all the time, and make sure that you're not using any terms that the person that's trying to learn how to play the game is not going to know. So same kind of principle applies here. Number 8 is not including cost targets. This is an interesting one just because, we operate primarily as sort of a third-party development firm for people. So people will come to us and ask us and say, hey, here's a product. We'd like you, to design it for us and hire for that. We also manufacture products for people as well. And a lot of times people will not give us cost targets. They'll just come in and they'll say, hey, I need it to be as cheap as possible. And, look, I completely understand where that's coming from. But at the same time, there's a lot of decisions that are made, and having a budget, a lot of decisions that are made from an engineering standpoint, and having a budget and understanding what you're operating under. We very frequently will finish way under budget, right? It's not a problem. Somebody comes and say, hey, we want this product can't cost more than $300. And, we were able to bring it in for, just a little bit over $100. It was a more sophisticated product, but, that was fine. Sometimes people are also just afraid of, if they give a price target, that they're going to kind of, they're setting the bar and saying, this is what the price is going to be. And, they don't want to leave leave themselves some room for negotiation or work and say what they can do. But having a cost target is going to be really, really important as early as possible in the product. It will also, it's going to guide the whole design. It's going to guide the selection of the components. And it's also going to guide when you're evaluating features early on. You may want some features, and those features may be putting you over budget. And then you can sit down and at least make an informed decision and say, hey, this is this can go or this can stay, and maybe we need to increase the price of the product or what have you. So getting those cost targets kind of documented as early as possible and saying it's what it is very important. When we have customers that don't want to give cost targets and just give us make it as cheaply as possible, that always rings a couple of alarm bells for us. The other thing which is sort of tangential to this to consider is, and I didn't include this specifically because most people do this, but just it's as an interesting point, is to look at the quantity that you anticipate making of this. And that's something that we always ask people when they come in and we're sitting down and working on the specification development, because a lot of times there can be trade-offs in engineering that are quantity-based rather than cost-based. For example, if you're only making a handful of pieces, let's say you're expecting to make 300, 400, 500 pieces a year, right? We may choose to have a machined enclosure instead of building an entire tool. That's going to be a custom enclosure because you're going to spend $50,000 or $100,000 on a tool, and if you're only making a couple hundred pieces, it may not make sense, and we may look at alternative ways to do it. In certain situations, we may, if the quantities again are very low, we may go with a more expensive microprocessor to reduce the development time, right? If we can get a fancier system, or even a whole single board computer that we can stick in a product, here's an opportunity for us to say, okay, we can cut the development time in half, which is going to save a huge amount of time, save months and months and months of engineering time. But your finished good is going to be a little bit more. But if you look at it over the full life of the product or on an annual basis, it's going to take, if we were to invest that extra engineering, the payback is quite a long time. So that's something you may want to consider. Conversely, if we know that this is a high volume product, if you're going to be making millions of these things you're anticipating, then we're going to maybe use not a microprocessor at all, maybe, or we'll go with a much simpler microprocessor and, shift some other stuff to try to keep the product cost as low as possible, some custom chips or whatever, FPGAs. And we're going to focus on, we have to keep the product cost as low as possible, even if that's going to double our upfront engineering cost to do that, because ultimately it's going to pay for itself, because, you're making so many of these things. So understanding the cost targets and understanding the quantity targets is really important, and not looking at those is going to be a mistake. Okay, let's move on to number 7, insufficient research on regulations, and particularly international I'm highlighting here. So one of the things we always ask, one of the things we always look at is, where are you going to sell this, and what are the regulations in that area for this product? And we do so many different types of products here at Mars. I mean, there's certain core competencies that we have, some industries that we've been in for many, many years that we understand intimately, those like garage door openers and things like that, where we are actually part of the UL group that develops the safety regulations. But for a lot of other types of products, we are either going to have to do a research phase, or we're relying on the customer to let us know, hey, these are the regulations that are involved. And unfortunately, sometimes that is not adequately researched, or more frequently, we're fine in the U.S., but then all of a sudden the customer who says, hey, we're not planning on selling it in Europe, or even Canada, our close neighbor, will often have different regulations. And they'll say, don't worry about that. Just here's the UL regulations or whatever, and you need to worry about the FDA, et cetera. But then, we go, they want to sell it in Europe, or they want to sell it in Korea or whatever, and all of a sudden the product is not legal over there. And we got to go through a lengthy and costly redesign process in order to make it work. We're doing that actually right at the moment, where a product that we designed to sell in the US and Europe, we were told that that's where it was going to be, and now they're moving into Asia, and Asia has some different regulations for some of the areas of the product, and we are having to redesign it just so they can sell into that market. So if you can identify that early on, and again, then you can make some judgments. Okay, it's going to cost me a little bit more to design it for all these, but I know for sure I'm going to do it, or I'm not going to do it. At least you're going in with your eyes open. So number 7, insufficient research on regulations. The number 6 issue is one of my favorite areas. I love this so much. Is and I'm being sarcastic there, in case you didn't detect that from my voice, is not researching the patent landscape. So this is kind of related to regulatory, and again, when you're getting into a new product, understanding your competitors, understanding patents that are out there. We will, if that's part of our charter, then we can do some patent research and read through patents that you're aware of, and come up with designs that are not going to infringe on those patents. But again, that's kind of a collaborative process between when we do it, between us and the customer. But if you're developing your own product, it's very important for you to make sure that you understand patents. You don't want to get out there and then all of a sudden find out that the item that you've just spent a year or 2 years developing is not going to work in the marketplace, because you're going to suffer a lot of litigation over patents. Typically, bringing in, if you bring in a patent attorney, if you have a patent attorney, they will do patent searches and things for you, so you can, get more confidence that you're going to be in the clear. That's number 6, not researching the patent landscape. Number 5 is leaving user interface decisions until it's too late. Now, user interface, a lot of people think about that as just, like what's on a computer screen, right? Or on your phone, right? What do I touch and click and drag and zoom? How do I do all that kind of stuff? But user interface is more than that. It is it's the complete gamut of the way that the user interacts with your product. Okay, it can be something as simple, buttons on a garage door opener. Where are the buttons going to be located? How do I want them to feel? What kind of sensory thing is it going to be? But also in terms of an interface standpoint is what happens if I hold a button down too long, or a button, if I just lean on a button and hold it there, what is that doing to my user interface? Or do I have, overloaded functions? Do I have multiple functions on the same button if I do a double tap versus a single tap? How do I give feedback to my users that something is happening? If something takes a while, do I have a light that comes on to make sure a signal was received, or that an operation is in progress? Or how do I give people warnings about issues with the product or errors that it got? If I've got an error code or something that happens, how do I inform the user about that? How do I let the user know they've got something wired wrong or plugged wrong or something like that? There's a vast variety of it, and pretty much every product, if it involves users in some ways, it has some type of user interface. And sometimes those user interface decisions, you want to make them as early as possible, particularly if they're going to inform your mechanical design. But if you're not sure about a user interface decision, I highly, highly recommend trying to do mock-ups as early as possible. As soon as you can get something into either your own hands or the hands of from some prospective users, even if it doesn't do everything that you need it to do, or it's just kind of a mock-up, it's going to go a long way towards having you understand what's working and how people interact with the product. There's a whole science of human-machine interface design that I'm not going to get into here. But that's certainly one of the strong recommendations always, is to mock things up as quickly as possible and get them into people's hands. If you're doing computers type stuff, if it's an app or a web interface or something like that, there's a really good program called Mock, MOQ, that will let you very quickly prototype those types of designs. If you are just if it's a mechanical product and things like that, again, even if you can quickly 3D print something, even if buttons aren't necessarily operating, but at least where they're located, how the product sits in the hands. We've even done like computer mock-ups using Mock for physical products, just to show people like the sequence of lights that are going to be on an appliance or something, and just make it blink red or blink green and stuff like that, so that people can see it and try to understand it. If you're at all kind of getting involved in this user interface stuff, I highly recommend a book called The Design of Everyday Things by Donald Norman. It's a fantastic book. I have a stack of them in my office. I give them out to all my engineers. Whenever we have a new engineer join, I make sure that they read a copy of that book. It's very near and dear to my heart. So I recommend that you check that one out if you're at all interested in this topic. And really, the perils of leaving this too late is hopefully self-evident, but you're gonna find, so either hopefully you'll find out later in your process that there's a problem and people aren't effectively using your product or get confused by it or something like that, and then it's gonna cost you money to change it. The later in the process that you change something, the more it's going to cost. Worst case, you're not really going to properly test it at all, and it's going to get out in the field, and then you're going to find out that people are having difficulty using it and you're getting bad reviews because it's just tough to use. Plenty of stories about this on the internet, plenty of horror stories. So try to focus on the user interface and get the user interface specified as early as possible, as is practical in your product design. So that's number 5. Hey, number 4 is not having a test method for every specification. So one of the things that's unfortunately too easy to do is when you're doing your spec. That's great. You're listing all your stuff. You're going through and you're creating your spec. But then later is, how do I know that I've achieved this element? And that's something that you need to think about, while you're writing the specification. So what that means is, first is kind of twofold here. I bring this one up because all the time people give us specs and we look at it and we're like, well, it's a little fuzzy. We don't really know what that means. We don't really know how we're going to test it. So as I kind of indicated, there's two different issues that can arise from this. One is just the specification that is not measurable, that it's fuzzy in that sense. So for example, saying like the product is comfortable in a user's hand. Okay, that's a spec, I guess, but how do I test that? How do I know that I've achieved that? It's comfortable in my hand, but does it need to be comfortable in a 5-year-old's hand? Does it need to be comfortable in somebody that's 7 foot in their hand and how they use it? What does that actually mean? That's not a clear specification. So that's one type. It's just a type where it's more fuzzy, like it needs to be pleasing, or just those types of things that are just more subjective than objective. So it's always challenging to say how you're going to know that you've achieved that goal as part of your product. The other type is just not knowing how you're going to test something. For example, you can say for your product, like it's got some sort of liquid or something in it that's subject to, say, mold or something. I don't know. Maybe it's some organic type product, right? And your specifications say, it won't get moldy over, the course of 10 years or something like that. It's like, okay, how am I going to test this? Are there certain or other types of molds? Do I know of laboratories that can do this kind of a test? Am I capable of doing this kind of test? Is there some kind of an industry standard where this is the way that you test for this type of longevity or resistance or something like that? If not, maybe I have to go to a different type of specification. Maybe I have to change it to a waterproofing specification, maybe like an IPC type specification where I say that, water intrusion can't be more than this, because I know if there's no water in the unit, I'm not going to have any mold. So you've got to, and think about how you're going to test it. And sometimes you need outside labs, and you can bring in some consultants or whatever to look at that. So there's no harm in that, and that gives you a much stronger footing of understanding what you're designing and how you're working. So on our standard specification form, we've actually got 2 columns on it. So the first column is the actual specification itself. And by the way, we organize them in like this nice outline numbered format so that we can reference them when we're doing ECNs or changes or anything like that. Everyone's got a reference in the spec. But then the second column is the test method for that specification. So we build it right into our spec form. And then when we have our validation testing, we basically say this is the spec number that we're testing, and this is the test method, and this is the test result. So you can tell, okay, at this stage in the development, when we're doing a design validation, when we're doing it, these are the items that we know we've tested, and we've all agreed that this is how it's going to be tested. So that's you may consider adopting that kind of a format for your specification, or having it as a secondary document. Maybe if you don't want to clutter up your main specification, at least having a secondary test document spec of this is how we are going to test every single one of these specifications. If you don't know how you're going to test them when you put them in, you're going to get into trouble down the road. Okay, let's move on to number 3. Inappropriate detail for the current stage. This used to be 2 different numbers. I guess we could have called them 3 and 3A, but I didn't want to bump one off, and I felt it was actually combined. Originally, it was too little detail in your specification and too much detail in your specification, which obviously sound contradictory, but really they kind of coalesce into this inappropriate detail for the current stage. And what that is that's not taking into consideration that your specification is a living document. And very often when you're starting out, you don't know what you don't know. I have yet to see a product specification that is 100% complete at the start of a project. Every single product spec is going to evolve. It's going to get added to. Things may even get deleted. And so it's important to both put in the effort initially when you're sitting down at the very beginning of a project and with your team or with yourself, depending on how you're structured, and putting together the specification. It's very important to spend the time to do that. But it's also important not to get super hung up on nailing down every last little detail. It is totally fine to put in TBDs. There shouldn't be TBDs everywhere in every single specification. There should be some level of of definition of what your product is. But if you don't know exactly the vibration test that you're worrying about right now, or exactly how a certain interface is going to work with people or whatever, that's totally fine. The key here is to avoid paralysis, right? A spec that is 80% there now is way better than a spec that's 100% there, but you've waited another 2 months before starting anything on your project because you didn't want to do anything until your spec was completely nailed down. Because I guarantee, first of all, it's hard to really understand what you don't know until you get into it. But also, it's going to change, right? Things you spec'd out that you thought you wanted, it's going to turn out you didn't want, or things are going to be really, driving your cost and making your product much more complicated to get certain features and things like that. You can't be paralyzed by having everything in at the same time. Now, on the flip side, we've seen many projects where it goes all the way through and customers do not update the specifications throughout the life of the development cycle. Decisions are getting made. Things are in emails, things are here, things are there, right? Information is all over the place, but it never makes it back to that spec. The spec is, just collecting dust in a drawer somewhere. Although I guess now it would be collecting dust on your cloud file server, which isn't quite as good a metaphor. But it's just something that's was created once, and maybe everyone once in a while it gets dusted off, but it's not really being treated as a living document that it deserves. So at the later phases, you should have all that detail. If you're getting into some of your final engineering design reviews and you still got TBDs in your spec, you've got a problem. Beginning phase, not a problem. End phase, problem. So that's what I mean by inappropriate detail for current stage. So the key suggestions there are to, again, don't get paralyzed early on. A partial spec now is better than, just dragging your feet and either having no spec at all because you're just worried it's not going to be complete, or just not even starting on a project because, you want to make sure that every last little I is dotted. But at the same time, and that's why it's good to have a professional project manager running your project. That's one of their big responsibilities is as those decisions are made, make sure that they're going back to the spec, doing, engineering change notices and doing new revisions for the specification to update it, changing those test criteria, changing everything that needs to be updated in the spec. So, number 3, inappropriate detail for the current stage. Now, number 2 is not something that you might have considered. I think it's really important, and that's why I put it up here as number 2. And that is inartfully said, I understand, but not having a non-team reviewer for your spec. Now, we talked way back, I think in number 9, about not using terminology, that was being consistent in your terminology and not using undefined terminology. And this is somewhat related to that, but the idea here, again, is that your spec needs to be clear. And the problem is particularly when you get to, kind of the end game, as you're going and you're adding stuff to your spec and things like that, but even at the early stages as well. What may be clear to you as the project manager who has put together the specification and the whole team that's kind of lived and breathed the spec, hopefully, is it may not be clear to an outside person. And it is really, really important that for a spec to be a useful document, it's really got to be understandable by everybody. And if you're getting too close to it, what may seem obvious to you or things that may not be stated that you have in the back of your head it's going to be picked up by somebody else. So I think it's really, really valuable at all stages of the project to have a spec reviewed by somebody that is not involved in the team at all. A properly written spec, you can take somebody, anybody, and plops the spec in front of them, and they should have a really, really good idea of what the product is, how it's supposed to work, how the operations are, and things like that. So having somebody, almost like an editor, right, that can do a close review of the spec at all stages is going to be really, really invaluable for turning up problems. The hardest spec to find, the hardest spec mistake to find, is the spec that isn't there, the specific item that isn't there, and the reviewers will have a much better chance than you at picking up those kind of absences. If a spec is there and it says that it should be, go up to 110 degrees, but you don't say whether that's Fahrenheit or centigrade, right? That's a really easy kind of thing to find. Something that's just written down in the spec that's not clear or not right. That's going to be easy to find. The things that you forgot to say, that you forgot to put into the spec, those are the ones that are going to be more challenging for you to find, particularly as somebody who really, you mentally understand what the project is, so you kind of fill in those blanks yourself. Having somebody outside the project be able to go through the spec and read it is going to be your best defense of finding those types of things. Okay, so this brings us now to number one, which is very exciting. Number one is just not having a specification at all. We have been called in to help out and try to recover projects that have run on the shoals of issues, and so many times they just don't have a spec at all. They can explain to us how the product is supposed to work. Maybe somebody wrote up a user manual or something like that, but there is no real detailed specification, and that's always the first thing that we do when we try to recover that. Certainly if you've, the bigger the team, you can intuitively feel that it's more obvious. But even if it's just you, one person, you're working on your own project, write the stuff down. This type of project development, it takes a long time, and it's very easy for little details to get lost and lose track of the regulatory stuff that you need to do, or some of the storage conditions environmental stuff that you need to do, or some of the human interface things that you need to do, or some of those TBDs that were out there, right? Having it all written down in one place is going to be invaluable for every single project. And yet, you're here listening to this talk, so hopefully that means you either already appreciate the value of a product specification or have some idea of what, some idea of the value of it. But we have seen over and over again projects where there is no product specification at all. Just a couple of jotted notes. So please don't make that mistake. A product specification is that's the heart of your project. It's the document that you always should be coming back to. We, like many development organizations, we use a phase gate approach to our project design. We have usually 4 or 5 key phases, and to pass through those gates, one of the things that's done is going through the specification line by line and saying, we've met this, we've met this, we've met this. This one we definitely agree that we were going to leave it until the next phase or whatever. But it becomes the heart of the project, and it's so important to keeping you on track and to ensuring that everyone's on the same page, talking the same language, and I guess most importantly, just to know when you're done. Right? If you meet all the specifications that are in your document, you're done. And if you're not done, then that means that there's an error or an omission in your specification document, because that's the definition of done. So without that, you get into those projects where you're just kind of wandering through the forest endlessly, trying to just, tweak this or play with that, whatever. You don't have that goal in mind. This is your finish line document. Okay, so let's just recap the top 10, the 10 items that we talked about here. Number 10 was poor environment and lifecycle specifications. Again, you want to look at operating environments, storage environments, transportation environments, but also end-of-life type things, or user repair or access, or technician repair. Make sure that everything is in line with that. Number 9, inconsistent or undefined terminology. Is everything understandable in the spec? Is every term used in a consistent way and you don't have multiple terms for the same concept? Number 8, not including cost targets. You need to, again, this product spec is your finish line document, and part of that is the cost targets. How much do you need to manufacture this thing for in order to be able to sell it into the market? Number 7, insufficient research on regulations. This is particularly important of identifying the international markets that you may be going into, and that you understand the regulations that are involved there so that you don't design something that's ultimately going to be not appropriate for the other places that you may want to bring on as a phase 2 or a phase 3 release. Number 6, not researching the existing patent landscape. Patent litigation can be a real problem in certain industries and certain types of products. So it's worth investing time and even money to bring on a patent attorney to do some searches in the space that you're interested in and make sure that if it's an area that you're not familiar with, that you learn about any patents that may be out there waiting to trip you up. Number 5, waiting too long to spec out the user interface. And again, user interface is everything that the user touches. It's not just a display or an app or something like that. We're talking about button pushes and indicator lights and even how you change batteries. Make mock-ups as early as possible to try to avoid this problem. Number 4, not having a test method for every specification. You want to make sure that for every single item in the spec, that you've got a identified and documented test procedure and test criteria. Number 3, inappropriate detail for the current stage. The beginning, don't get too hung up on every last little thing. It's fine to have some TBDs. Just get moving, get going, get your prototypes going, get your learning happening about the design. But by the end, you need to have all that stuff buttoned up. So just keep track of where you are. Number 2, not having a non-team reviewer. Critically important to have somebody outside of the team that's just seeing the spec for the first time read through it and give you feedback in terms of things they don't understand, things they think might be missing, and things that may be contradictory. And finally, number 1, not having a specification at all. Hopefully, if you've sat through this entire talk, you understand the importance of having a spec for your product. So that's the presentation. I appreciate your time, and hopefully this will have given you some good information. If you have any questions, please leave them here in the chat, and we'll be responding to questions in the chat. And or you can email me directly at gme@marsint.com. You've got my email right there on the screen. So hope that this was informative, and best of luck with all of your product development in the future.